Hi guys, so welcome to the Building Expressions chapter. In this particular chapter guys, we're going to learn to use flowcharts in order to construct algebraic equations. Now as we discussed in the very first lecture, an expression or an algebraic expression is basically just a mathematical phrase that consists of variables, which are letters as we know, and numbers. So again, let's have a look at this flowchart that I've drawn as an example. So we had an input number of x. Now as we know, x simply represents any number. We don't know what the number is, so we use x. And as we work our way down the flowchart, we start building up that equation or expression. So x, we do x plus 7, so that becomes x plus 7. Then we multiply the x plus 7 by 4, which then gives us 4 times the entire x plus 7, therefore we have the brackets around it. And then finally, to finish off, we have divided by 3. So we have the entire 4 bracket x plus 7 over 3. Now, again, just rehashing on what we've learned so far, the bracket and the number next to each other simply means multiplication. Because as we know, in algebra and linear equations, we do not use the multiplication sign. Finally, we have the division sign here, written out as a fraction, because division, or the sign for division, is not used when it comes to algebra. So guys, by the end of this chapter, you will be able to use these flowcharts in order to be able to construct algebraic equations. And as well as that, we will also use our backtracking method to go back to the original input number or input letter. So we'll use inverse operations in this chapter as well to deconstruct the equations that we have constructed using the flowchart. So let's get straight into it. Alrighty guys, so let's have a go at this question. It says, complete the flowcharts to find the output number, which as we know is simply the final number. So let's have a look at part A. It says we start off with y as the input number, then we go minus 3. So that simply becomes y minus 3. Straightforward. Then we take y minus 3 and we divide it by 6. So as we know, when we divide it by 6, we have to take the entire y minus 3. So it becomes y minus 3 over 6. Because in linear equations, we do not use the division sign, we use it as a fraction. So y minus 3 over 6. And then finally, we have plus 3. So we have the y minus 3 over 6, and we simply add a 3 to it. And that right there, guys, is the final output number for the flowchart in part A. So now, let's do part B. We start off with p as the input number, and we multiply it by 4. So p times 4. As we know, we don't use multiplication sign in linear equations. So p times 4 simply reduces down to 4p. Because we know that the number always comes first, and then the letter. Then 4p, we add a 5 to it. So that becomes 4p plus 5. Pretty straightforward. And then we finish off with dividing it by 3. So we take the entire 4p plus 5, and then we divide it by 3. So that right there, guys, is the output number. So guys, again, you can see that just like chapter 2, this is fairly straightforward to construct equations or find the output number using flowcharts. So using what we just did in part A and B, I want you to pause the video at this stage and please have a go at part C all on your own. Alrighty, so let's start with x, then we go divided by 5. So x divided by 5 is simply written as x over 5. Pretty straightforward. Next part is adding a 3 to it. So x plus 5 is where we are. And then we simply add a 3 to it. So x over 5 plus 3. And then finally we have the entire thing there multiplied by 4. So we have x over 5 plus 3. And the entire thing has been multiplied by 4. So we put it around a bracket. Otherwise, if we just put x plus 5 plus 3 next to 4, it would look like the 4 is only being multiplied to the x. However, the 4 is being multiplied to the entire thing. So we put x over 5 plus 3 into brackets. So that right there, guys, is the output number. Were you able to get the same? I hope you were. If not, don't worry. There's plenty of opportunities to just improve the way we work through these flowcharts. So now let's move on to the next question. Okay, so now the second question here says, draw a flowchart whose input number is x and whose output number is given by the following expressions. So we know that we have to draw a flowchart. Let's just get drawing with the first one. Now I don't quite know how many boxes it'll take to get to the final answer. So let me just draw 4 for now, and then we can add or take away as we go along. So the very first thing is our input number is obviously x. So then we need to work our way down to the right hand side going this way to find the output number, which is given by 5x minus 7. So the very first step in this expression, guys, is to find 5x, as that is the closest thing to x at the moment. So 5x is simply multiplied by 5. So that will give us 5x. And then the second thing that we have to do is minus 7, which will give us 5x minus 7. So we don't need that final one there. So that right there, guys, is the flowchart that describes 5x minus 7. Okay, so let's work it out for 3 bracket x plus 6. So let's draw the flowchart first. We know that the input number is going to be x. There's going to be another box, maybe another one, and maybe another one. So again, let's just draw out a number of boxes, and then we can take away and add as we need it. So since there is a bracket here, guys, as we know, brackets in BODMAS we need to do first. So that indicates that we need to do the bracket part first. So inside the bracket we have plus 6. So we have x plus 6, which gives us x plus 6. And then we take the entire bracket and we multiply it by the number 3. So we are basically just doing times 3. That gives us 3x plus 6 in brackets. There you go. Again, we didn't need that last box there. So that right there, guys, is the flowchart that describes 3 bracket x plus 6. Okay, so let's do part C now. Input number is x. Then the very first thing we have to do is the minus 8, as that's the closest thing to 8. So working our way through the right hand side, we have minus 8, so x minus 8. Then the next part of this is the divided by 7, or the over 7. So we divide that by 7, and we get x minus 8 over 7. There you go. That right there, guys, is the flowchart for part C. Now, guys, we've worked with brackets, we've worked with couple of types of questions. So what I want to do, as always, pause the lecture and have a go at part D on your own. Alrighty, guys, so let's work our way through this particular flowchart. So we have a bracket once again. So as we know from BODMAS, we need to work out the brackets first. So the first thing that we have to do is the over 5 here, as that's closest to x. So we do divided by 5 as the very first operation. We get x over 5. Then we have to do the second part of the brackets, which is plus 6, which gives us x over 5 plus 6. And then the final thing we have to do is the multiplied by 3, because that will then multiply the entire bracket by 3. So we have 3x over 5 plus 6. So that right there, guys, again, is the flowchart that describes 3 bracket x over 5 plus 6. So fairly straightforward method, guys. I hope you got the same answer. If you didn't, please don't worry. Pause the lecture and just rewind back and just go through the entire process again. And if you do enough questions, just like the one I've provided in the worksheets, I promise you that you will be getting used to this particular process. So now let's move on to the next question. Alrighty, guys, so there's a new question now. It says complete the flowcharts using inverse operations to find the input number. So guys, we now need to backtrack back to the input number and just basically fill out these gaps that we've been given. So let's have a look at part A. It says x is the input number and 3 bracket x minus 4 is the output number. So first let's go forwards and fill in these gaps here to see what will give us 3 bracket x minus 4 at the end. So the very first operation, as we know, is to do with the brackets. So let's solve the brackets first. So the very first thing we have to do is minus 4, which will give us x minus 4 in that middle box there. Then the final step that we have to do is obviously multiply by 3, which will give us that 3 at the end there, which basically multiplies the entire bracket by the number 3. And then backtracking, guys, we have to do opposite of times is obviously divide, so divided by 3, and then opposite of minus is simply 4. So if we have a look at it, we have 3 bracket x minus 4, and then when we divide it by 3, those 3's simply get cancelled out to return us that x minus 4, and then we add the 4, so minus 4 plus 4 ends up giving us the letter x again. Let's move to part B. We have x as the input and x minus 4 over 3 as the output. So again, minus 4 is the closest thing to x, so that's the first thing we have to do, which will give us x minus 4 and then x minus 4 in the middle. And then finally we have divided by 3, which gives us the x minus 4 over 3. Then we simply do the opposite for the bottoms. We have plus 4 and multiplied by 3. So if we have a look at it, we have x minus 4 over 3. When we do multiplied by 3, those 3 will simply get cancelled out. And then we have x minus 4. And when we add the 4 again, minus 4 plus 4 will get cancelled out. So we will end up with the letter x at the start. So now let's move to part C. We have x again, and we have 3x plus 5 at the end. So the very first step is multiplied by 3, which gives us 3x. And then we do plus 5 to give us the plus 5 at the end. So we have 3x plus 5 as the output. Then again, just going through our opposites. So plus 5 becomes minus 5 at the bottom. So 3x plus 5 minus 5, those 5's get cancelled out, leaving us with 3x in the middle. And then finally, we have divided by 3. So the 3's get cancelled out, and we end up with the x here. So guys, now, again, as we always do, please do pause the video at this stage and have a go at part D all on your own. Alrighty, so we have x as the input and 4x minus 7 as the output. So step number 1 is multiply by 4 to give us that 4x. And the next step is obviously minus 7 to give us that 4x minus 7. And doing the opposites, we have plus 7 as the very first arrow going backwards, and then we have divided by 4, which then returns us the input number of x. So guys, as you saw, the using of flowcharts makes it a lot easier to build in expressions as well as do inverse operations to solve equations. However, as we move forward, we are going to scrap the use of flowcharts and basically do the calculations in a manual form in order to solve the equations. However, it's very straightforward. The flowcharts are there to help you sort of gather your thoughts and understand how equations really work and how to actually construct equations. However, it's just as simple to do it without them. So guys, that brings us to the end of the building expressions chapter. I hope you got a very good understanding of how flowcharts are used to construct and deconstruct algebraic expressions. In the next chapter, we're going to go one step further and start solving equations using inverse operations. So thanks guys, and I will see you there.